Fine, it's time for us to build a pattern counter and offer its functionality through a dynamic library so that a client written in language like Python can avail its functionality. For example, I'm showing a dataset that is used to train the glass type classification. So this is the data I got it from Kaggle's, where we have the refractive index of the glass and the composition of the glass and the type of the glass. But we are not going to create any classification algorithm now. We are going to do a very simple task. If I type, if I search for wind, and which is a pattern, I want to search in this corpus of data, then I need a result of 163, right? So the pattern is wind and this is the data. So these are the two ingredients which we are going to pass it to the foreign function. So let us quickly have a look at the design. So this is a high level design that we want to realize in the long term. We call it a use case realization diagram also. So let us read it from left to right. The Python client invokes this foreign function getCount that accepts two pointers, the path of the file and the pattern to count. The foreign function accepts this request and transforms the pointers into string slices and hands the slices to an executor. The design savvy folks call this arrangement a combination of fuzzer and adapter. It's an ambitious design. If the file is huge, the executor may decide to chunk them into an array of lines and span a required number of worker threads to accelerate the counting operation. But for this episode, I restrict my temptation to write an executor as it may be a distraction. I promise you a session on this later. Let me keep it very simple now. Then we have our hero, the counter, the does the actual counting. So let us first build the counter and progressively expand our design ideas. Let's start by creating library project this time rather than a binary one. So cargo new hyphen lib and pattern counter is the project name. So we have a pattern counter now and we have a cargo.yml. At this moment it is not possible for us to distinguish a binary or a library because there is no information available in this cargo.yml XML to do the differentiation. We'll shortly introduce more ingredients here. And if you go to the SRC, there is a small variation. Normally you will see a main.rs. Now you are seeing a lib.rs, and it has our great test and ready for us. So let us make this as file to check whether the test is failing or not. Cargo test. Yes. A failed test is an indication that we are in the right place and we are all set to start. Probably if you have followed the episode 2 of Rust Eliminated, where I made it very clear that how to organize your test, because tests are our guiding light and we have to give you a proper treatment for them. So this is fine. So you can have your test in the lib.rs, but personally I prefer a different way of handling this, because in the long run, when your code is getting expanded, having the test in the same lib may be very difficult to manage. So my preferred way of doing this is, so before I do my preferred way, let me just to show you, this is also a nice idea for very small projects. What you can do is that you can have a function here, do something, and you can make this function to return some value, and let us do, so this, how to invoke this function now. Asset equals do something should be 2. Let us again make this to fail. Let us give some 3 here, though we are expecting 2, and this do something is not visible to you. So one way of doing that is that you can uh, use create. We need finally to do something, and where this do something, so you can call this do something by simply invoking this use create do something. So if you want to see this how this is working, okay, because the left is 2 and the right is 3. So for very small projects, for very small uh, test, probably you can follow this strategy. I'm not saying that this is a bad idea, but I have my own preferred way of organizing the tests. So what's our idea is to create a package within this src. Let us create one more directory. uh, what is that? We can have a name pattern, and within the pattern we can create a file called as counter.rs that is going to do all our operations of counting. And this pattern, within the pattern, let us create our test.rs where we are going to house all our tests, and there is going to be a mod file where we are going to pub mod this counter, and then we won't pub mod that, we will normally will provide a mod of this test. And the test so this lib.rs is just going to use the and then the counter. Let us write our first function, fn do something. Let us try to invoke this. So it is, the counter is living within pattern, and we have pub mod pattern, and in the counter we have do something, we have test.rs, and let us use create pattern counter, yeah, and we can call this counter dot to, and this is not a public method, because make this as pub counter dot do something should be available to us. Yeah. Come on, 1, let's make this as 99. And we have more dot rs, so then we have to configure this as a test. And now our test is cannot find value counter in this scope. So we are directly imported the do something directly here, and we have the lib, and let us check whether we are able to access the from everywhere. Yes, now do something is also available here. If this is FFI, and if everything is fine, then I can call me do something from here as well. So all the green lights are an indication that our environment is ready. So we did that in a lightning fast. Let us check whether the test is really respecting our Where are we now? Okay, it's working. And in the test, what we have to do is I have to call this do something. Call the test. Yeah, one passed and everything is fine. So this is a quick way in which you can house your test as a subordinate to a package called as pattern. So we are going to have all our business logic in this counter.rs, and the test is the one that supports the evolution of the design, and the more.rs is more like a table of content file where we will declare the ingredients of this package, and we are offering the counter as a public one so that I can use this directly from my library, because as we are going to have more than one collaborators here, like counter, foreign function, interceptor, and then executor in the long run. So we have to neatly package them, and package them at a later time may be very difficult. So that's why I am following this kind of a test organization. And let us close all those things that is what is not required for us. Let us focus on our tests and the code. So the test is now going to drive the evolution of this counter. Okay, so we will open this in here. So we will close this test here, close this, and then we'll give more room for our test on the left hand side and the code on the right hand side. So what's going to be our code? So it's a time that we have to do some matching. What we are going to do the first test. So it should count pattern, and let us write a method count off. Let us pass a string here. I created some interesting strings for us to use. So that means I have there's a divine place closer to Chennai at Tirunamalai. It's called as a Ramanashram, and I am providing this as a count of Ramanashramam, and I am expecting, and the pattern is Rama. If I offer this Rama is appearing 2 times here, R-A-M-A here. Right. So R-A-M-A, it starts with Ramanashramam, and there is one more R-A-M-A here. So if I pass this string, that's a source of data, let us assume that, and Rama is Rama is the pattern for this, and I'm expecting 2 out of this, and this is a count of, and I'm expecting this counter to have this count of method. So let me change this as count of. So the first is a string slice str, and let us call this as let me call this as a line, for example, line. In this line, and this pattern, what I am expecting is a number, and this count of is single letter. So let me make this as a, what are the errors here? No, do something. So the library we were using this do something. So let us make this as count of, and count of, or at this time this is just a placeholder, and I want to focus on the test rather than the lib rs. So Okay, so now it is just focusing on my test. Let me close this lib, which is acting like a placeholder for the time being to check all the parts are linked to each other. Let me close this with your permission. Now I have the test.rs and the counter.rs, and I am not using this line and the pattern because my intention is now to make this test to fail. So let us try to progressively expose the hidden design for the given situation. So let us provide some simple letters. Let us a very small step RAM and RA, and there is only one match for this. And this is an opportunity for me to show you how the getChars method is working in a for loop. So basically we need to return a counter. So, and we know that it needs to be mutable, and let us return the counter. Okay, fine. And if you run this, and this is a failing test, and let us see uh, what we can do with this line and the pattern. Let us first take the pattern dot get chars, and if I offer next to this, let us check what is the resultant value. So for people who are new to the iterator, this may be useful, and for others, please be patient. And I am providing. So one is the first time I am expecting this to print R, the second time A, and the third time it should be none because I have crossed the boundary of this slice. So R, why it's not going to A, because I am initializing this cars dot pattern dot cars each and every time, and rather let me keep this somewhere, and let us give a name for this pattern rider. So any spelling mistakes? Yeah, the error is because this pattern rider, as we are calling the next each and every time, it is mutating this rider. So let us give this pattern rider also as a mutable one, so that we can move from one location to another location. And now we are not using pattern chars dot next, rather we are using this pattern rider dot next. Now let us see the result of this operation. So R is printing, A is printing. As we have reached the end of the slice, the pattern dot chars is returning you a none. Okay, and we have this in our mind. And let us try to print the so we need one more guy, line dot chars. So let us call this as line rider. If you want to differentiate with a printer line, then we'll just provide for the time being a boundary. Now you are seeing RA and then a none, and RAM and then a none. So the way a for loop works is, it works until it is encountering a none. And now we got some decent idea about how the next on this std str chars is behaving. So this is sufficient for us to expose a latent design. So we are providing RAM and a RA. So the moment, so I will fix the, we have to check the first character with this first character, second character with the second character, and unfortunately in pattern.chars we do not have index, and we are not supposed to use any index, because when we are using a non-English character, the solution that what we are offering is likely to break. So at no point in time we should use index. That's what we should have in our mind. And so the count can be incremented the moment this pattern rider returns a none. So it's RAM. It's not printing the none, because the way this for loop works is until this line rider is so this is calling it line rider dot next every time this loops into, and this works as if while line char is not equals none. So that is how you should read this for loop. So now we have this for loop that is giving us this line char. And in fact what saying that this need not be mutable, so let us keep this as not as a mutable one. Okay. So the next is if, then we'll take the first character from the pattern. Pattern rider dot next. So this will give us the pattern rider dot next. Let us keep this somewhere. Now let us check what happens to this. Okay. And I'm providing a question mark because these are all option, and that implements a debug that we will discuss later. And let us print what happens to this. So line char and then the pattern char. So when the line char is R, the pattern char is sum of R, whereas this pattern char is more of an option. That's the reason it is printing sum and none. So let us check something like this. If let pattern char equals none, or there is one more method, pattern char dot is none, is none, then let us increase the count by 1. Okay, and let us remove this pattern char and the line char. And that is line char is not at all used. And if yeah, pattern. So let us call this as a pattern result. The result is none, we are increasing this with 1. If the result is not none, then we are getting this character. Now result is guaranteed to be some value. Let us unwrap it and keep that in the pattern char. If pattern char equals line char, the matching is still happening, so we can simply continue this. If it is not the case, if pattern char is not equals then a line char, then what we can do is let us rewind this pattern rider. Rewinding means pattern rider equals pattern dot chars. So what will happen now? So we are taking the first character of the line, and then we are taking the first character of the pattern. If the result is none, it is an indication we have reached the end of this RA, end of the pattern. So we are incrementing that by 1. At the same time, we should know that this the line char moved to M. So we will print the line char and the pattern char each and every time. And let us print the pattern char. At times it is required for us to So if the result is none, we have reached the end of the pattern, and then we are increasing this by 1, and then in fact we have to again rewind this pattern rider, because in case if there is a RA is coming again, we will get into trouble. But we are not going to write that code. Let us make this test to pass now. That's what our aim. So it passed the test, and when it is passing, normally this won't be get printed here. So let us make this to return some. Let us make this as 2, so that you can see at least what is happening. The line character R and R, line character A, and the pattern character is also A. Sorry. This is result. R and R, line A and the sum A. Line N, pattern character none. So as it has pattern character is none, it is we have to increase this by 1. I put this as 2 to show you the system.out.println messages here. Okay, so when a test is passed, normally this println will not be get printed here. Okay, so now this first test is passed. Is there something that we can refine here? Let us, if there is any opportunity for us to refactor this. If result is none, we are increasing this, else we are using this. Okay. So let do something like this. Let both these values be wrong. Let us check what happens now. Okay. R R A A M M, and there is no opportunity for us to check this result dot is none, because by the time this line carries line writer is completed its for loop. So if, let me print what is the pattern writer dot next here. So let us keep that original result as it is. That is 1 and RA, and for this also it should pass. So the pattern character is becoming none here, and we are increasing this only when the pattern character is none. So let us put an additional if condition here. If pattern writer dot next dot is none, let us again increase this value. Okay, because it is at the edge of the matching, and by the time the line writer exits the loop and this matching didn't happen, so we will again check if there is any chance if we use the pattern writer dot next to get that value, and if it is none, then we can increase this and test, and it passes for both the cases. What's happening now? And now it fails the first test, or RAAM. Pattern character is none. Yes, the moment we have reached a pattern character, if it is none is performed already, let us do the same rewind operation. Rewind means we will reinitialize the pattern writer with the pattern dot characters, so that now this result is none. It reached m. I mean the for loop reached the m, and when we are exit out of this loop, the result is already is none. So it is incrementing that by 2 times. So now we are reinitializing this when the result is none and when the pattern character is not equals line character. So again we will make this to cool. And now we go to the next test of Rama. So Ram, and when I'm sorry, I expect 2 times Ram. And let us I'm just committing this to test to show you this print ln, otherwise there will be too much amount of print ln, because we know that this is going to fail. So when the line character is at R, the ROM has just finished reaching its none. I mean the pattern rider has just reached the none, and we are reinitializing this pattern rider again here, reinitializing this one, so rewinding this the pattern rider by calling the pattern dot chars. So when the loop goes, the line character reaches A by the time the pattern character is picking up its first character. So Ideally, what we can do is, after we have rewind this pattern rider when the result is none, if there is a possibility for us to move one character back to the line char, that will be very easy. That will solve this problem. And let us check for if this line char dot move or back, sorry, line rider. Okay, there is a method called as advance back by. It's a reverse version of advanced by. So what we can do is we can provide a line rider dot advanced by 1. That is, it will go back to the the line rider will go back to R from A, because when this line rider is in R, we are in none, and when the line character is A, the pattern character is sum of R. And if we could advance this, then there is a potential synchronization between both the riders. Okay, so this is a feature that is available in the unstable library. So we cannot use this like for this given scenario. Let us think in a different way. So ideally, what we can do is we have to peek at the next character of the pattern rider. So we cannot control the line rider. The line rider will go like a time. We do not have any control over that. And at least we can adjust the pattern rider, which seems like a space that we can move forward and backward. Backward in the sense we can either move forward one character after the other character, or we can rewind to the initial position using this pattern.cas. So so the pattern rider, uh, let us speak at what the pattern rider has in its head. So it will be more like again the result equals pattern rider. Next we'll applying the pattern rider as next character, more like peeking at the head. And if that this has some character, double equals result, and if it has some character, and if that not equals line character, then simply what we can do is that we'll again rewind. This is more like a duplication of code, but let us do that for the time being to make the test to pass. And this result, let's have this result as a mutable one. Okay, so what I did is I attempt to seek the next character after I rewind the pattern rider. If it has some character, that is, and if it is, again, it is an internal check that whether it is none or not. Definitely it is not going to be none, but anyway, the only way that I can get the value out of an option is using an if let some pattern char equals result, and if that pattern character is not equals line character, so if they are mismatched, for example, we have some value next to ram as rama ram, and if it is ram, and if the first character is not matching with the subsequent character, then again I am rewinding this thing. So I am going to rewind this again in case the pattern character is not matching to the current line character. So it is just an ugly code, and I am just doing what is required for to make this test pass. The test is passed, but the code is very ugly. and there is a duplication of information. And if pattern can result dot unwrap, so it's more like if we make this else if instead of else, if we write something like if is literally moving the black block here, if let the sum of pattern char equals result so literally if we remove this and we keep two if loop if conditions like this, cool, it's passing. We have removed as many duplicate codes as possible. Let us have a look at the structure of this counter now. We'll remove this println. So we are writing this line character by character. We are taking the first character of this the pattern writer using the next. If it is none, we are incrementing the counter by 1, and then the pattern dot chars is used to rewind the pointer back because we have reached the end of the pattern writer. And again, we eagerly look into the first character of the pattern writer, and so the result now will hold always the latest pattern writer information. And again, this will come here, and if let sum of pattern char equals result, and what we are doing is we are again checking whether the pattern char not equals line char. If it is the case, then we are rewinding the pointer, I mean the pattern writer. So it's too difficult to explain the way this code is working using in English, but what we did is we have literally unearthed the hidden design using these test cases. So this is how we have created an algorithm to go through this the line under the pattern, and let us include few non-English texts. I have a great text already created for the test, and okay. This is a great slokam that talks about the importance of cordial relationship between people, and why hostility is not the right choice, that is against our knowledge. So I don't want to indulge further into this Upanishad. So the idea here is that this is what I have told in the agenda. Conflicts and hostility are caused by the lack of understanding, and using knowledge we will conquer the hostility, and we will establish a cordial relationship. And that is what this particular slogan is trying to say, or the slogan is saying this is what I am trying to understand from this Upanishad. And let me make this to pass. Okay, so now what I am getting is this starts with Om Sahana Vavatu Sahano Bhunaktu. It goes like this, and I am looking for the number of instances of Shanti, Shanti, and Shantihi here. And let us check how many times is Shanti is appearing. It is being called here Shanti, Shanti, and Shantihi. And I'm calling just the Shantihi here and running this test. Yeah, successfully passing this. And it is time for us to put another great saying that talks about the power of the lotus feet of Lord Muruga. It is from Tiruppugal and count off. If we pass this Uru enavum, Aru enavum, Ulad enavum, Iladu enavum, and if this is the slokam, and I am passing enavum as a such parameter here, and I expect how many enavum here is by the great saint poet Arunagirinatha. Enavum, 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 enavum. 4 times it is coming, and let us run this. Fantastic. So these are all the test cases that our counter program successfully passed. And let us have the most important thing. So there is a potential that we have to have some edge cases where the count of A, is it working? We should check this. Yeah, this is working. And let us introduce one more back test case where I have A and this is bigger. I mean the length of the pattern is larger than greater than the length of the line. So naturally it is too difficult for this to make any, it should be ideally 0 because this is working, but we can also put a simple check here if line dot, we don't want to get into all this for loop to do all the things. If line dot len is greater than line dot len, then we can literally return 0. This will be more safer. Fine. So now our counter is available, tested, up and running. There are several ways in which you can make this better. In fact, you can use a match on this result dot is none. That's also another idea. So if given some more time, we can further polish this code, no doubt about this. But the idea here is the best code is not written in a single shot. The test is helping us to discover the hidden beauty in a code. So now let us go to the second component. Now this counter is over, and now it's time for us to expose this functionality. Now we are not going to touch this executor. We are going to expose this functionality of count of directly through the lib pattern counter, and let us see that in the next episode. Thank you.